Today we're going to talk about evaluating inverse trig functions. When we do that, we did some of this last year when we used that inverse sine, cosine, and tangent, and we are going to do that again. But we're also going to refer it back to the unit circle. So let's look at this idea right here. Consider this idea. Name three angles that could satisfy sine of the angle is 1/2. So on the unit circle, when is sine 1/2? Well, we know that, and I'm going to use degrees just for consistency. We know that at 30 degrees, our sine is 1/2, and at 150 degrees, sine is at 1/2. But what if we keep going around? What if we went a whole circle? 360 plus 30, that's 390 degrees. 150 plus 360, that's 510 degrees. So we could keep going and adding more coterminal angles, or adding 360 degrees to find more coterminal angles that all have the sine that is equal to 1/2. And are there more angles? Yes, there are definitely more angles that we could use. And actually there's an infinite number, so we keep going around and around the circle. So if I just give you this question here, find the value of theta where sine of theta is 1/2, there are infinitely many solutions. So what we have to do is we have to restrict the domain of the inverse function so that we only are working with one angle. So we have one answer. So the domain, or the values of theta, our angle measure for positive and negative values, must come from connected quadrants that produce positive and negative values. So if we think about our trig functions in which quadrants they're positive in and which quadrants they're negative in, each function has one of each, a positive and a negative quadrant, that are connected. So if we look at sine, we know that sine is positive up here, and we know that sine is negative down here. So we want two connected quadrants that include our positive values and our negative values. So we could say quadrants, and just if you've forgotten, 1, 2, 3, 4. We could say quadrants 1 and 3, but they're not connected. Quadrants 2 and 3 are connected, so that would work. But what mathematicians have agreed upon is that we were going to use quadrants 1 and quadrants 4 as our domain for inverse sine. So facts about inverse sine of theta: inverse sine of a value equals theta. One fact is, it's also called the arc sine. In degrees, we go from negative 90 to positive 90. And in radians, we have negative pi over 2 to pi over 2. And this is just another picture to show that. Now over here, inverse cosine. Okay, cosine is positive in quadrant 1, and it is negative in quadrant 2. So facts about the inverse cosine, sometimes called arc cosine. In degrees, we go from 0 to 180, and radians 0 to pi. And then finally, the inverse tangent. Inverse tangent is going to have the same domain as sine, and this one can be called arctan or arctangent. In degrees, again, we go from negative 90 to 90, radians negative pi over 2 to pi over 2, Now you might say, well, why don't we say 270 to 90? Well, that, if I say 270 to 90 degrees, I'm talking about this part right here. So we say negative 90 to 90. And down here, we just have another picture to show that information. And on the next page, we have inverse sine, inverse cosine, and inverse tangent. Evaluate these expressions in degrees and radians using our unit circle. So make sure you have that out to refer to. Cosine of, or inverse cosine of 3. The way I like to think about inverse functions, when does cosine equal 3? Okay. That's the way I like to think about it. And you could use a calculator, but since I'm asking you to use a unit circle, you know it's going to be values that are nice, that we can find easily. Well, the cosine, inverse cosine of 3, that is outside our domain. Inverse cosine of 3, that doesn't exist because cosine does never equal 3 on the unit circle. So there are no solutions for this one. One is the tangent square root of 3 over 3. Well, we know that happens at a multiple of pi over 6. So this is either going to be positive pi over 6 or negative pi over 6. But since tangent is positive, it is going to be pi over 6. And in degrees, that is 30 degrees. One is sine negative square root of 3 over 2. So sine, we are going to be in quadrants 1 or 4. And because we are negative, we're going to be in quadrant 4. So when does sine have the square root, negative square root of 3 over 2? Well, looking at our unit circle, that is going to be negative pi over 3. Or negative 60 degrees. Now let's look at these problems down here. When is the cosine negative 0.5 or negative 1/2? Well, on the unit circle, we got inverse cosine, we are in quadrants 1 or 2. Cosine is negative in quadrant 2. So if we go back and look at that unit circle, cosine is negative 1/2 at a pi over 3. So in quadrant 2, it's going to be 2 pi over 3, or 120 degrees. When is tangent negative 1? Well, negative 1 for tangent means we are in quadrant 4, and tangent is 1 at 45 degrees, or pi over 4. And to get to quadrant 4, we have to have negative pi over 4, or negative 45 degrees. Then for letter F, in our calculators, we can do the inverse tangent of 0.34. So inverse cosine 0.34. And we get 70.12 degrees. Now, to make that into radians, you could either use our conversion factor, that equation that we used to use, or change your mode to radian, and then do the same thing, and we get 1.22. Either way works. Now down to these problems. Solve the equation cosine of theta equals 2 over 5, where the angles between 270 and 360. So we're going to do the inverse cosine of 2 over 5. And when I type this into my calculator, I'm first going to go back to degree mode because my restrictions are in degrees. So degree. And then inverse cosine 2 divided by 5. Now this tells us 66.42. You may say, well, that's not in between 270 and 360. This value here, the 66.42, is your reference angle. And remember, we talked about reference angles before. 66.42 is the distance away. This is the angle between the x-axis and your terminal side. But we want our angle to be in quadrant 4, 270, between 270 and 360. So if here's our initial side, our terminal side should be down there. And our rotation is going this way, so it's between 270 and 360. But this angle right here needs to be 66.42. So we are going to do the whole circle, 360, minus that little green part there, 66.42. And then when we type that into our calculator, that's going to give us the angle of rotation for this angle. Right? In the calculator, we end up getting 66.42. We end up getting 293.58 degrees. So that's this rotation here that satisfies these constraints. This problem here, we're going to do the inverse sine, but we are between 90 degrees and 270. Sine is positive right here. We're saying the inverse sine is positive 0.7. So when we do the inverse sine of 0.7, so inverse sine of 0.7, again, this is going to give us the reference angle of 44.43. Now, our constraints tell us that we're in this area here. Sine being positive means that we are right here. So the angle that we're actually talking about needs to go like this. And this angle here, let me erase the colors. This right here is going to be 44.43. So to calculate this rotation, we need to do 180, because that's half the circle. This flat line here is 180 minus that 44.43. And then we do that in the calculator. Minus 44.43. And we get 135.57 degrees. So with these problems, you have to make sure to look at the constraints that you are given, because the inverse, cosine, sine, tangent, all those things, that only tells us the reference angles. Now down here, we're going to be using SOHCAHTOA in these problems. When I do these problems, I always like to label my my opposite, my adjacent, my hypotenuse side. So here's our right angle. The side that doesn't touch the right angle is always the hypotenuse. And the side that doesn't touch our angle, we are talking about this angle here, theta. This side doesn't touch that, so this is the opposite side. And that makes this one the adjacent. We write out SOHCAHTOA. When we write out SOHCAHTOA, I like to underline what we're given. We know the opposite side, so I'm going to underline my O's. We know the hypotenuse, so I'm going to underline all my H's. S has two things underlined next to it. That means it's going to be sine of theta equals 5 over 13. So then we'll do the inverse sine of 5 over 13. Oops. So inverse sine of 5 divided by 13. And we get 22.62 degrees is our answer. These two problems are making us draw the picture. So what I'll do is we'll talk about drawing the picture for both of these. then I'll have you work and finish it and calculate it. So monster truck drives off a ramp in order to jump on a row of cars. The ramp has a height of 8 feet and a horizontal distance of 20 feet. Here's our right angle, and here is the angle we're trying to figure out. So that's our picture. For this pair problem, a kite is flying 115 feet above the ground, so 115. The length of the string from the kite to the ground is 150 feet. So if the kite's up here, the length of string is 150. Find the angle that the kite makes with the ground. So we're trying to find this angle here, and here's our right angle. So our pictures are drawn. Go ahead and try both of these problems. Once you are done, unpause the video. We can look at it and go from there. All right, so these are the answers. You can look at my work as well and see what I did, all the steps that I took, how I labeled things, and then the trig functions I use. So thanks for watching the video. Make sure to like it and subscribe.